Today, we're going to discover how mathematics is found everywhere, around us through patterns in nature, the Fibonacci sequence, and the golden ratio.
Many people think mathematics is only about solving equations inside the class. However, mathematics is present in nature, architecture, technology, and even in our everyday activities.
Let's explore our school and discover how mathematics is truly essential.
Whenever we buy food, we use mathematics to calculate discounts, prices, and change.
Although calculators make computations faster, mathematical thinking is still necessary to understand and solve problems.
Nature is full of patterns, and mathematics helps us understand why these patterns exist. Today, we'll look at three common natural patterns: spiral leaves, symmetrical flowers, and tree branches. First, let's talk about spiral leaves. Spiral leaves grow around a plant stem instead of directly opposite each other. This arrangement helps each leaf receive enough sunlight, air, and rainwater while reducing the amount of shade cast by other leaves. As a result, the plant can grow more efficiently. This spiral pattern is often connected to the Fibonacci sequence. The Fibonacci sequence is a series of numbers where each number is the sum of the two numbers before it. For example, 1, 1, next is 2, and 3, 5, 8, 13, 21, and so on. In many plants, the number of spirals you can count follow these Fibonacci numbers. For example, sunflowers, pine cones, and pineapple often have spiral patterns of 8 and 13, or 13 and 21. This arrangement helps plants pack their leaves or seeds efficiently while making the best use of available space. Next are symmetrical flowers. A flower is symmetrical when its petals are evenly arranged around its center. If you draw a line through the middle, both sides look the same. This is called symmetry. Flowers like daisies, lilies, and hibiscus show this beautiful pattern. Symmetry helps attract pollinators such as bees and butterflies because the flowers are easier for them to recognize on land on. Finally, let's look at tree branches. Trees grow by repeatedly dividing their branches into smaller branches. This creates a branching pattern that helps the tree spread its leaves over a larger area to capture more sunlight. These repeated branching shapes are an example of fractal pattern, where similar shapes appear again and again at different sizes. You can see this in trees like acacia, oak, and mango trees. These examples show that mathematics is not only found in classrooms, it is also present in the natural world. Patterns like spiral leaves, symmetrical flowers, and tree branches help living things grow, survive, and function efficiently while creating the beauty we see in nature.
Another fascinating mathematical idea is the golden ratio, approximately equal to 1.618. It is often associated with balance, proportion, and beauty.
Faces with measurements closer to the golden ratio are often considered more symmetrical and balanced. However, this does not mean they are more beautiful. Beauty is influenced by many factors, including culture, personality, and individual preferences. The golden ratio simply shows how mathematics can help explain patterns and proportions in the human face, providing that math is present not only in nature but also in ourselves. Architects also use the golden ratio to create buildings that look balanced, harmonious, and visually pleasing. They apply this ratio when designing the height and width of the building, the size of windows and doors, and the arrangement of different architectural elements. Many famous structures are believed to reflect the golden ratio, such as the Parthenon. While not every building follows it exactly, the golden ratio has inspired architects for centuries because it creates proportions that people often find attractive. This shows that mathematics is not only used again for calculations, it also helps shape beautiful and functional buildings around the world.
Our investigation shows that mathematics is not only found inside classrooms.
It exists in nature, technology, art, architecture, and our daily lives. Thank you for watching!